People, welcome. We're going to get started here. Um, we're going to talk a little bit today about furnace boards. That is a fall preseason. It's part of the fall preseason. Also, we're going to talk a little bit about types of ignition styles. So the furnace boards can come in two different major styles. They can come in what they call hot surface ignition, and some are direct spark ignition. Different ways we light the fire. Okay, for say a furnace or a boiler. And then we're going to talk about another very important control for this type of climate, which is the low ambient head pressure controls. We're going to cover, what these controls are, what do they do, why they're needed, and why would somebody choose ICM controls as compared to maybe some other brands out there. So first of all, we'll talk about what we're doing here. So we make drop-in furnace control board replacement. Now, if you live in the Northeast, it's going to get cold, we're going to have heating. A lot of times that heating is natural gas. If it's in the Northeast, it could be propane, it could be other types of fuels, but something has to control that fire. You're going to create a fire. You got to create heat somehow. And something's got to control that. There are other sources of heating devices, including geothermal, which uses heat from in the ground. But we're going to talk today about the more traditional style heating, like natural gas, which would run heaters in your residential homes or boilers and things like that for hot water heating. So why do you need options for these furnace? Why do you need furnace control boards to begin with? So if your furnace, if you live in the Northeast, you know how important a furnace is. It's sort of like if you live in Texas and you lose your air conditioning. In the Northeast, if you lose your heat, you're going to be freezing to death. So it becomes very important. You need a solution and you need it fixed. We can get down into the sub-zeros, and so trying to get an original manufacturer board may not be available. They might have to wait. There could be tariffs involved, which means that you might have a longer lead time and you could have more cost. Manufacturer board almost certainly is going to be more expensive than our boards, because we can do this in a vertically integrated environment where we build all of the parts ourselves. We don't have to wait for parts to come from overseas and so forth like that. So ICM control has a full line of both hot surface ignition and direct spark ignition. Now, those are the two major type styles of ignition. So you're either going to light the flame with what I call a cigarette lighter type of thing. If you ever people that have a little bit older might remember the car light, the cigarette lighters on a car. You would push the button in and you get an element that glows cherry red. That's like a hot surface igniter. And then you've also got the direct spark ignition, which almost everybody has seen, a little spark rod that sparks and lights flame. You can ICM replaces many popular OEM brands like Goodman, Rheem, Lennox, Trane, Carrier, and so forth. We have universal replacements, and we have most of ours are drop-in, form, fit, functional replacements. And we'll talk a little bit about that. We have a universal option, but a lot of people want the exact thing. They say, hey, I don't want to play around with wiring, extra wiring or whatnot. I want the exact model. We make it. We make the exact drop-in replacement. All the wires fit, and you just drop it in and go. This makes it easy for the technicians and less time for that they have to charge their customer. So, very general overview here. How do they work? These go in your furnace, right? So these are the brains of your furnace. These are the brains of your furnace. They control all the safety, all the operation of the furnace, including the ignition of the gas, the ignition sequence, the inducer. And what the inducer is in the old days, you used to have a chimney that would vent your gases. Nowadays, everything is you create that vent. You create that chimney effect with what they call an inducer. So you're blowing that gas out, that non-combustibles, the carbon monoxide, stuff like that. Uh, with that comes pressure switches and safeties and valves and flame sets, circulating blower, everything that goes on in your furnace cycle, all controlled by the brains of it, which is the controller. Next. All right, so let's talk about ignition. So we talked a little bit about hot surface ignition already. It's a type of ignition which uses an electrified rod that gets very hot, red hot, to ignite natural gas into a flame. There's usually a defined warm-up period. So just like when you press your cigarette lighter in on your car, you would have to wait a few seconds for it to get chilly red, and then you can light your cigarette. Well, same idea here. Maybe 7 seconds or so for that cal rod element or whatever it's made out of to get cherry red. And that's gonna be ready to support ignition. Soon as the gas is allowed into the chamber, lights that flame, and we have a flame sensing circuit that senses that flame for safety, because you would never want your gas valve to be open and be pouring natural gas into your house, right? So there's a lot of safeties in a furnace circuit board. And that's one of the things that we pride ourselves on is we try to make our products as safe as possible so that nothing can go wrong with them, you know? So then, and we talked about the flame sensor. So yeah, so that's basic, very general understanding of a hot surface igniter. You'll see these in a lot of boards. They're pretty reliable. The only thing is, some people will say these are a little less reliable than spark ignition because they can burn out. But I don't find that to really be true. I find out spark ignition is more troublesome because you have to have a very good ground. And sometimes houses don't have a good ground. And what that means is that, you know, on your 3-prong plug, how you have a hot, a neutral, and a ground, well, you have to have that good ground in order to make good connections with the spark ignition. So let's talk a little bit about what we offer. One of our most popular boards is the universal board. So why is this important? Why do we want a universal board? Well, let's face it, you know, distributors and servicemen are going to want a go-to board. They're going to say, hey, if I got one board that'll replace almost 200 other boards, why would I want to be searching for all these other boards? And yeah, the drop-in replacement's nice, but if I got a simple to use universal one, I'm going with that, you know, because it's going to reduce your truck stock inventory. All right. It's going to eliminate trips back and forth to the distributors. It's going to reduce and eliminate confusion, right? A lot of times guys don't know what board to put in there. I got this carrier board, they take it out of the furnace. I can't find an exact match. Well, let's try this one. They don't necessarily cross it properly and you get messed up. With the universal board, because it processes so many boards, as long as you find the part number of that original board in that list, you know you got a direct fit. So you reduce inaccurate crosses. Which is, I have to say, a very common thing in tech support, you know, we get all the time. So why would you choose now ICM over, let's say, the OEM board or some other company's universal board? Do you see that? Yeah, I'm going to stand in front of it. So we make these here, right here in the US. We're supporting our local economy. We're supporting our factory people. We're helping keep jobs in Syracuse. We don't have a lot of long lead times because we're bringing in parts and building this stuff here in what we call an ISO 9001 certified facility where we follow all the general practices that are called out by that agency. Plus, it's a vertically integrated building, which means that we build everything from the ground up. We mold the plastics, we put the parts on the circuit board. And so we don't have to wait those long lead times for stuff. We have very durable circuit board design using many cases double-sided through-hole construction, which means we solder our circuit boards on both sides through a via, which gives an extremely tight bond for all of the parts. Now, a lot of OEM parts, they only might be single-sided. It's cost reduction, great, but it's not as durable. And we conformally coat all of our boards to reduce moisture and dendrite growth. And you know, when these things, you know, figure out where do you think a lot of these boards are? a lot of furnaces are in a basement. Now, sometimes it can be in an attic too, but a lot of them might be in a moist, damp basement. So that conformal coating helps with some of that as well. We are all that's UL listed, ETL in this case, ETL Intertech. And means that it went through stringent safety protocols, so it's tested to make sure that it's gonna meet to all the standards of an agency that, such as ETL. And we have US-based live technical support with real technicians. We're not depending on somebody calling AI if something doesn't work, or someplace overseas that may not be able to give them the help that they need. We have technical support right here in the US that we can help you with any problems. So these are all good reasons why you would want to choose ours, maybe over maybe an OEM product, which if anybody's ever tried to get a hold of an original equipment manufacturer like Carrier or Lennox, good luck. If you're not somebody that's a high end on the technician's level. So operation, again, same thing as the other one, controls all functions of the furnace, including timing, trial per ignition, gas valve, safety system switches, flame sensing, and 100% lockout for safety. Safety is always what we gotta be thinking about when we're talking about furnace boards, because they're very dangerous, and that's why there's so many safeties involved. So here's some other examples of some popular HSI boards that we make. For example, you can see we made a 280 for Goodman and Texas Instruments, White Rogers. These are all of the companies that this board replaces. And then we got Carrier products in the 281. One of our most common ones is the 282B. We sell thousands of those a year. So that's a very popular board for us. Look at all the parts that it replaces, all the different Carrier boards, original equipment boards. Again, these are drop-in replacements now. These ones, you literally cross it to the part number, and it's a form, fit, and functional replacement. You drop it in, wire it up, done. ICM 288 for your ring products. Lennox, we got the 289. We also got the 2813, and which covers a lot more Lennox products. We also got different HSI boards for other companies as well. But these are just a sample of a few. Again, the value of using the ICM over the original equipment. Again, made here, far less expensive, easily available to local distributors, less lead time for technician, means repairs go faster for the homeowners, which we know when it's cold outside, we want our heat. We don't want to be without heat. I don't know if everybody's ever been in that situation. I remember once I was in that situation where I was living at my home at the time and my mom's furnace went out. And boy, I tell you, it wasn't that bad in the house. It might have been 55 in the house, but boy, when you're in the middle of the winter and it's cold outside, that 55 feels like sub-zero. It's awful. Durable circuit board design and US-based support. So here's some other hot surface ignition type controls at the bottom. All right, let's talk a little about the other type of ignition. Now, that was all hot surface ignition. Now we got other types of ignition, okay? We got a spark rod. This is a lot like what you see, like a gas grill might be able to have it, like it's gonna have like a sparker where you press the button, it goes, and you get that little spark. Same idea here. You've got a control board which has a little spark coil on it, and that spark coil sends out so many thousands of volts, usually in the kilovolt range, and the reason why it's got to be such high energy is because it's got to jump a little gap between a ground rod and the center in order to make that little spark. And that's why you got to have a good earth ground. So it's very important you're using spark ignition control boards. The house should have a good earth ground. A lot of the older houses, like before 1950, they a lot of times didn't run a earth ground. They used the neutral as the ground in the house. And so that could be a real problem when you're using direct spark ignition. You gotta have a good earth ground, which means there's a rod driven in the ground that creates an earth ground that's part of your main electrical box. So this uses a center spark rod with a ground rod and a board mounted spark coil to generate a high voltage spark. That spark lights up a flame or lights a gas that's under pressure. So the center rod, emits the spark energy, which jumps a gap to ground, mounted directly next to the spark line, the presence of natural gas, the flame lights. Now, once the flame lights, you have to have some way of saying that flame is on. Because again, you never want the opportunity for your gas to be running and your flame not to be on. Because then you got just raw gas pouring out. So that's why we have that all of these things have a flame sensor that senses the presence of the flame. Again, this type of ignition requires rubber. Some popular DSI boards would be our ever famous ICM 291, the 292A, that's the big one. The 2911, these are Trane, that's Modine, but that's part of Trane, I believe, as well. We got the 2913, 2914, and you can see the little spark coil there on here, a little spark coil on all these, and that's what's generating that high voltage to jump that arc, that gap between the ground and the center rod. And again, these boards do the same thing. They monitor all, it's the brains of the furnace. They monitor all functions of the furnace, all the safety of the furnace, and output to the blower motors as well. All right, so before we move on to the next section, which is low ambient control, does anybody have any questions about furnace boards, why we need them, and what makes ours any better? Is there anybody that has any questions? Anybody online has any questions about our furnace boards or anything specific? All right, and then we'll move on to the head pressure control. So what is a head pressure control? All right, why do we need head pressure control? What does that even mean? So if you go into Wegmans, you go into by a cell tower, cell towers have to run year round. And the equipment that's in that cell tower gets very hot, it emits a lot of heat. You have to have freezer cases and refrigeration all year round to keep your produce, your meats and your produce all refrigerated. So we have to have this refrigeration all year round. So we live in the Northeast, we know we get into very cold temperatures. So if we didn't have some type of way of controlling the head pressure in the system, our refrigerators, when we tried to run them, our air conditioning units, when we tried to cool those towers, they would freeze up because as the temperature, it gets colder outside, the pressure in the system goes down. I had kind of an analogy I thought I'd share with you. It's sort of like, you ever know when the first cold snap day, your tires go down low. All of a sudden your tire pressure sensors are saying you got a low tire. What? 5 minutes ago it was fine, and the other day you were running was fine. It's because temperature and pressure are related. So as the temperature drops, the pressure inside of a sealed system drops as well. That's why your tires go low. Same thing with the air conditioning. You can get such a low pressure that it could cause your system to fail, freeze up, and then you got real problems. So again, that's why we need it. Supermarkets, grow houses, computer rooms, they all still require air conditioning in low ambient conditions. To prevent the loss of perishable goods and damage to sensitive equipment, we need these type of controls. You could get liquid slugging in the evaporator from the refrigerant, getting like slushy and everything, it'd be no good. And by regulating the system pressure, we can keep that running year round, no problem. We'll explain a little bit more how that works, but let's talk about the value. Why would you choose an ICM head pressure? Why would you choose the 325A? Well, we used to have different SKUs. We used to have one for high voltage. We used to have one for just refrigeration because there was no 24 volts available in refrigeration. So you couldn't use a control voltage. We used to have ones for that accepted certain types of reversing valves. So with the 325A, we made it universal. We took all that guesswork out. Can't tell you how many calls I used to get. We used to have a 326 versus a 325, and the 326 was for refrigeration units, so everything had to be line voltage. 325A was for residential, or not residential, but like supermarkets and things like that are cell towers, they were just like, they had 24 volts available. But the problem is they would look and they'd say, well, wait a minute, I'll just take this one. But they weren't paying attention. Hey, the 326 can only accept line voltage reversing valves and a heat pump, for example. And then they would have the wrong one. So we had a lot of mixed up people getting the wrong controls, and some didn't understand the voltage of their motor. Their fan motor was higher than what it needed to be. So by going universal, we take all that guesswork out. It's far less expensive than alternate models or methods, I should say, of low ambient control, because if, let's say, other options might be more expensive variable frequency drives and things like that, which can get very costly. So having the low ambient control is a much less expensive way of achieving. Now, this is very popular in grow houses because it's all about profit with those grow houses, and they want to keep their plants at a certain temperature, a certain moisture level. So rather than spending thousands and thousands of dollars on big fancy VFD equipment, they can buy one of these at a fraction of the cost, and they don't care if they go through, they beat them into the ground. They don't care if they go through once every 2 months. Because they're so lower cost and they do the job, they'll just beat them to death and they'll just keep using it. So these are a nice low cost option. It uses what they call near field communication technology. Now, that's a nice fancy term for the same type of technology you see in Apple Pay or contactless payments. It's just there's an antenna that's in this device, and there's an antenna in your cell phone. And basically, you're going to download the ICM Omni app, and the Omni app now takes place of all the knobs that used to be on here. Now we're reducing costs because we don't have to buy those knobs. We don't have to buy those. Yep, we don't have to buy those rheostats. We don't have to have all those extra pieces. So that's going to save money and build time and be more reliable. And you can. It's more tech forward where you're using an app, modern technology, and you can control everything right from the app. And that makes it universal again, because now where we used to have models that could only do pressure with what they call the pressure transducer, and then we'd have separate ones that could do it with just a sensor, temperature sensor. Now this can do both, either or. So it's more reliable, more accurate than basic potentiometers. It doesn't require the internet, doesn't require Bluetooth. It's just your app. That's it. And the universal operation uses truck stop. So a guy doesn't have to carry 3 or 4 different controls on his truck anymore. Just this one control. And he could program the thing right in his car. So if you ever, I don't know how many people have had experience, I know Phil has, some of these big rooftop units where these go into, they're up on the roof. Can you imagine if like in a cold December day, the wind's blowing like crazy, you're up and it's up on the roof, trying to put in a head pressure control, that could be very, very uncomfortable. So by being able to program and get all the programming done ahead of time, then he's just got to go up on the roof to just throw the wires on and take off. You know what I mean? So it just makes it a lot more convenient for the techs. And it makes it a lot more convenient for the stocking distributors, because now they don't have to worry about giving people the wrong control or all these different models that used to be out there. So how does it work? Best way I can tell you how this works, which almost everybody's probably been familiar with, if you've ever run a dimmer switch in your house, same idea. You got a variable resistor on the wall, which is that little knob you're turning. All right, the sensor is no different. And this, they call it a thermistor, but it's the same idea. It's a variable resistor. So it's changing in resistance. As that resistance changes in accordance with the coil temperature in this case, in your case, it's just you turning the knob. You turn the knob on the wall, the voltage going to the light bulb gets less and the bulb gets dim. You crank it the other way and it gets bright. Same idea here. We just got it going on with a temperature as a function of that, creating that resistance change, which then changes the output speed to what they call the condenser fan unit. And by pushing less air past the coil of this condenser, we control the pressure that's in the system. All right, now I know that to some people that might not mean a lot, but what that means is it's sort of like, think about the radiator on your car, how that air pad pushing past that radiator keeps the coolant cooled and keeps the car cool. Same idea. Imagine if you could control that air pressure, and they do. Sometimes you'll hear your fan, they have electric fans that come on after you shut your car off. You'll hear the fan come on. Well, that's because it's sensing that the temperature is too hot. You want to keep that fan running. So this kind of does the same idea, but it's doing it all through sensors and saying, okay, as my temperature increases, my pressure in my system's increasing, my fan's got to increase, and then vice versa. We'll take a glorified dealership. All right, so again, why do we need it? Low ambient control helps prevent evaporator freeze up, low pressure cutouts, liquid slugging, and damage to your compressors that would happen if you didn't have this type of control. We have special heat pump bypass circuitry on this device and a heat pump, when you're in heating mode, you don't want to regulate the speed of the fan. You want to push as much air past the coil as possible in that mode. So we can bypass it when you're in heating. But this control is smart enough to know when you're not in heating and you want to go into cooling again. Because again, this is low ambient control for allowing you to run air conditioning in the middle of the winter and refrigeration. So it knows by sensing the reversing valve direction that, okay, I'm in cooling now, let's go into variable speed. But if I'm not in cooling, I want to just bypass. So it has that smarts. And it replaces all the old legacy controls. Very important to all the sales guys, replaces all the old ICM legacy controls, 333, 325, 326, 327, all those controls now replaced with one control. Using, of course, that nice near field communication, the ICM Omni app. Now, one thing that's important that for the sales guys as well, is that these are not meant for electronically commutated motors. Now, for this group, that's not as important, but for the salespeople, that is very important. Electronically commutated motors already can vary their speed electronically, and these do not work with that type of control. These are for standard, what they call permanent split capacitor motors, or motors that have a capacitor. AC motor with a capacitor. So the old-fashioned type motors, just regular old motors, not ECM. We have other head pressure controls, like the ICM 713, that does work with electronically commutated motors, but not these type. These are for your standard controls, air conditioning units, refrigeration units. Okay, so this is just a little quick sample of what our app looks like. So you can see we've used this near field communication technology for our universal timers as well. So, this 5-wire timer can replace hundreds of the old legacy timers. Remember, we used to have a timer that if you had, back in the old days, if you wanted 24 volts at 3 seconds, we'd make it for you. If you wanted 120 volts at 10 seconds, we'd make it for you, but we can't do that anymore. So, now these universal controls are a thing. So the 325A is in there. You just get created a new program, and here's your parameters. Very simple app. You set your probe type, either temperature or pressure, whichever type sensor you're using. You set your set point based on your refrigerant that you're using. If you're using, like, say, 410A, and you're using the temperature probe, then you'd set your set point at 100 degrees Fahrenheit, which correlates to about 320 PSI, which is about what you want to keep your head pressure at for using 410A. You set your hard start, which is giving you a little bit of full speed operation. That's more for if you don't have ball bearings, fancy nice ball bearing motors and your fan blades and all that stuff for your condenser fan. You might have a sleeve bearing That's a little bit drier, so you might have to get a little bit of hard start to wick some oil out of that bearing. So that's what it's there for. And then just your minimum output voltage is your fine tuning for how much variable speed you want to allow. Some fan motors don't like to be variable speed as much as others. So it depends on how cheap the motor is. You know, some of these cheap motors, they take everything out of them. So you try to choke them down and it doesn't work so well. So, but we give you that option as well. So it's a lot of like, functions that you can do, a lot of parameters you can adjust, make adjustments to make sure that it works for pretty much any standard PSC motor, condenser fan. And that would be it, I think, yeah. So if anybody has any questions about head pressure controls or anything like that, I'll open the floor up. Anybody online as well? If you got any questions, please, now is your time. But also, you can always contact me at our 800 number, technical support, 1-800-365-5525. You can also send an email to info@icmcontrols.com. All of this information is available on our website. And please don't forget to visit our website as well, where you can get information on all these controls and more.
For the